here. You can see okay? Yeah. So another word for distribution. It's just, you could say, how the data is spread out. So you'd like to know how many small values, how many big values, things like this. Okay, and then frequency is just how many. Yeah. Okay, so there's a little bit of basic vocabulary. So, does anybody know this word now? Tally.
Yeah.
Yeah, what's it mean? Yeah. Now, what does it mean? You see, it has a few meanings. So the first one is as a verb.
Count. Tally.
To count. Very good. I think what a lot of you were giving me was the noun. So what is it as a noun?
Line.
Yeah, it's just a mark for counting, you know. And it's also an adjective. So what is it as an adjective?
Count.
Yeah, no. What's its meaning as an adjective?
More.
Think about using it as an adjective to describe something. So like a tally person, a tally man.
An accountant.
Like an accountant, yeah. So as an adjective, it would mean someone or something that's counting.
That's all. Count.
Yeah, but that wasn't a sentence. Counting. As like a person who counts. You know. Okay. So let's go on to some examples now. So a question could be something like, tally the grades, and let's put some data down here. So we'll just say A, B, B, A, C, B, A, B, B, C, C, A, B, C, A, C, B, A. Okay, so we want to tally this. So this is our first little example here. So I'll just give you a minute to get this data. And I'll show you what it means to tally this, how to write it down. Okay, you got that? Yeah. So this is what it means to tally. So first we write down all the possibilities. So you could have in this data set you could have an A, a B, or C as an example. And then we use our tally marks. So let's see, we have an A, 3, 4, and then every 5 you draw a diagonal line here. The B's, let's see, you have 1, 2, 3, 4, 5, 6, 7. And then the C's, 1, 2, 3, 4, 5.
There are 6 A's.
Did I miss one? 1, 2, 3, 4, 5, 6. Okay. Here we write F for frequency. Here's the data. Here's the tally. So this is 6, 7, and 5. And it's quite normal to put at the bottom here the total. Okay? So what's that then? 15? No, 18. 18 there for the total. And then finally, what is quite normal as well for the tally is to put in a percentage. So this one would be 6 over 18, which is about 33%. This one here is 5 over 18 and 7 over 18. I don't know, what's 5 over 18? 28%? Okay, so then the last one here has to be 45 if you want the total to be 100. I know there's decimals, so.
It's 48%.
What is? Not 28?
7 over 18.
Is what? What's 5 over 18?
22.
22? Someone told me 28.
28.
No, it is 28. It is
28.
27777.
This is definitely 28.
Yes.
And this is 33. Okay, so what's the last one? 7 over
38 over 39.
It's 39.
39. Okay, thank you. 39. And the total here? 100. Yeah, okay. So this is what your tally looks like. Now, when you're coming to typing up reports, you can actually leave this part out in a typed report. This is only for counting purposes here. So if you ever were looking at some kind of study and you know, perhaps this is like treatment A, treatment B, treatment C, then you'll see a table like this with frequency and percentage. Okay, so that's the first example. So we'll go on to one now that's a little bit harder. It is nice though having this here because it lets you visualize how big each group is. So you can see that you have, you know, kind of, well, I didn't quite, I made these lines further apart than these ones, so this one looks bigger when it's actually smaller. That doesn't mean not spacing them right. Okay, can I scroll down? Yeah. Now, we reach a complication if our data is not discrete. So, you know, maybe, what were you collecting, like pH or something? Yeah, so, you know, maybe you'd have something like 6.1, whatever, 7.2, 8.1, 6.3, 6.5, 7.2, 8.3, 8.4, 7.0, 6.8. I don't think any two of those are the same.
7.2.
7.2 came up twice? Oh, let's take care of that then.
7.4.
8.2 then, okay. Now none of them are the same, right? So you realise it'd be pretty pointless to put this in a frequency table, because if you did, you'd have something silly like this. You would have 6.1, one of them. 6.3, one of them. Right? So this is a little bit pointless to put this into a frequency table. So instead of using a frequency table, we use something, yeah, a grouped frequency table. Grouped. Well, the question now is, how do we divide up each group? So let me just add in a little bit more data here. Let's say, have I got 6.9, 7.9, 8.9, 8.5, 8.0. Okay, that's pretty significant. 1, 2, 3, 4, 5, 15 there. Okay. All right. Yeah. Okay, so I'll just give you a minute to write this down because I'm going to show you how to make a group table. Yeah. Oh, this would be, we could make this like pH values or something.
It's non-discrete or discrete?
Oh yeah, this one here is not discrete. So the word, does anyone know the word for not discrete? What's the? Continuous. Yeah, so you can call it continuous.
How can you differentiate?
How? Well, this is what we're going to look at now. Are you not making notes?
I'll just look for the video.
You do? Okay. you just can't get enough maths. You have to watch it twice, huh?
Slightly.
Yes. Yes. Okay. So, the first thing we need to decide when we're grouping, it's good to see what the smallest value is and the biggest value, because this will help put a range on what we could have. So what is the minimum value here?
6.1.
6.1. Okay, and the maximum?
8.9.
8.9. Here. Yeah? Okay. So, the problem here is how to subdivide it. You know, don't write this part down just yet, but you might think, well, maybe you could go 6.1 to 6.5, or maybe 7. Who knows? Like you want to check that you have a reasonable number of boxes. You don't want to have too many or too few. So I think we can all imagine having one box that says 6.1 to 8.9 would be pretty useless, because then you just would have 15 in this box. So that's pretty useless. Likewise, it's kind of pretty useless to have 6.1 to 6.2 and then 6.2 to 6.3, because what would be the problem with that? Too many. In fact, you would have more boxes than you would have data. You would have like 30 boxes, but you only have 15 data points. So 15 of the boxes would have 0 in it. Again, that's kind of silly. So the way we can calculate how big to make each box is, first we need to see how much we have, how much data we have. So how many data points do we have?
15.
It is 15, isn't it? 1, 2, 3, 4, 5 times 15. Okay. Now, can you just take out your calculator and calculate the square root of 15 there?
3.87.
Okay. 3.87. So what you do, now, oh, by the way, I should say, what I'm about to show you is only a guideline, okay? It's only a guideline. It's not like there's some rule that says you have to do it this way. I'm just trying to give you some guidelines on what's a good proportion to use for your boxes, okay? So one little trick you could use is you take the square root of your sample and you round it up. So that is 4, and you always round it up. So this gives us a guide for how many boxes we have. We should have 4 boxes, so that's a good start. Okay, so let's make 4 boxes here.
Question, sir.
Yeah,
So if you get like 3.1,
you make it 4 also, yeah. Huh? Sealing, yeah, sealing function, yeah. Okay. Right, so this is pH, so I'll put pH here and frequency here. Okay. Or actually, I'll just write pH in the middle. So pH and frequency. Now, it's really important that you have your inequality closed on one end and open on the other. And I'll explain why now in a minute. So I think, what do I usually do? I put the close on the left. No, I put the close on the right. I'll explain why. Suppose you had something like this. Let's say you had pH for the first box, let's say, is between 1 and 2. And then for the next box, the pH is between 2 and 3. So if you had a pH of 1.2, which box does that go into, the first or the second? The first, obviously. And 2.1? Second. Well, what about 2? Ah, now see, it's a problem. The boat, yeah, because it's here and here. So this is why it's important that when you make your inequalities, that it's not closed on both ends. It's closed on one of the ends and open on the other end. Now again, it doesn't matter which way around you do it, but the usual thing, for me anyways, is to make the one on the right closed. Okay. So pH, pH, open, closed, pH, open, closed, and then pH, open, closed. I already have not quite the right space in here. Okay. So you might think, I know what the first number here should be. What should that be? 6.1. Well, yeah, this is the thing, because if I use 6.1, what's the problem? 6.1 won't be in it. So you might say 6, or maybe you might say 5.9. There's a question of how much do you go over the edge? And likewise here, you might think, well, what could we use?
You can use the maximum here.
You could use the maximum here, 8.3. But again, 8.9. But again, if you went a little bit over at one end, then it would be good to do the same thing on the other end, so you're not having a skewness, that it's still symmetric. So we need to go over a little bit here. So what we need to work out first is how big the data range is. So what is the biggest minus the smallest? So what would that be there? 2.8. Now, if you divide that by 4, now you'll get 0.7, but this isn't a good number to use, because if you would start here at 6.1, then you go up by 0.7 until you get to 8.9. You have the problem I just described a moment ago, that you're starting at 6.1 and you don't really want to start at 6.1. So you want to start a little bit to the left of that. Okay? Is this 6.1 I said is the smallest?
Yes.
Yeah. I don't quite want to start at 6.1. So dividing by 4 isn't quite good. I want to make it little bit off. I'll say
6 words.
I want to make the pieces I jump up in a little bit smaller. So let's just see, what about if I divide by a number that's slightly bigger? So if I divide by 5, what do I get?
0.56.
0.56. Now just think about that. Would that work? So if you just take your calculator out, what do we get here? Let's see. Let's open the calculator. Waiting. I want to know, if you start at 0.56, do you go over or under when you get to the end here? Well, you can only add it on 4 times. What would happen? Are you too short or too big? Too short. So, yeah, dividing by 5's a little bit bad here, isn't it?
So 5 is not good, 7 is not good. What do you want?
Now, I'm trying to get us to work it out, because it's the only way you can remember how to do this, because it's not like it's a formula in the exam, you know? Okay.
You just have to guess to me.
No, so what you do?
We should fix the range.
Yeah. Correct. We want to fix the range. My tip here is you should start off by saying what number you want to start with.
6.
Now, not only see, but you're just picking 6 because it's a little bit less than 6.1. You want like a good system for picking how far to the left you go. Okay? So what I would do is 2.8 divided by 4, that's equal to 0.7. So anything that's between 0 and 0.7, that's how far to the left you'd want to go. Okay, so you said 0.1 because you went from 6.1 to 6. That's fine. But you could go to 5.9, you could go to 5.8, you could go something like this. Pick anything that's between 0 and 0.7. So maybe you want to pick something like 0.3. Or maybe you want to pick 6.
So
That's fine.
So why is it 0.5 not work?
No, I'm on to something else now. No. I want to know what number I should start with. Everybody's saying we should start at 6 because they can all see that 6.1 is the smallest. I'm trying to say, what is your limit for how much to the left you can go? I don't want you going any more to the left than 0.7.
Okay, 0.3.
You could go 0.3.
Okay.
Well, you could go 6. That's fine. Okay. So, in other words, you have a few choices here. I would be happy if you picked any number from 6.0 down to as far as 5.5 maybe. Okay, so 6 seems like a nice number to start with for this example. So I want to start with 6. And where do I want to finish? Again, the same logic. I don't want to go too far past my upper one, which is 8.9. So I want to stay this close to it. So what do we think? 9. Okay, now we can, as Young Peng said, we can fix our range. So we're going from 6 to 9. How big is that? 3 units. And how many boxes do we have? 4. So we should go up in values of 0.75. 9 minus 6 over 4. So the next one here would be 6.75. And this one here, 6.75. And this one here, 7.5. And here, 7.5. And here, 8.25. And then you finish on 9. Again, this is not the only answer, but this gives us a nice box. It's easy to read. There's not too many boxes. You can fill it in. So how many are between 6 and 6.75? Between, is it 3? 1, 2, where's the third? 3.
Yeah.
3. Okay, between 6.75 and 7.
It's 4. It's 4.
Who's the fourth one?
6.3, 6.5, 6.0.
Where's 6.0? There's no 6.0. Between 6.75 and 7.5. How many is that? 1, 2, 3, 4. 4, yeah? Okay. Next one, 7.5 and 8.25.
3.
1,
4.
2, 3, 4, 5.
No, 8.25.
Oh, sorry, I shouldn't have.
8.4.
I shouldn't have those two, should I? 1, 2, 3. Who else? 8. 4. Now I know the last one must be 4 because the total is 15. Now look at what you have. This is a very nice group table. You have 4 boxes, and each box is roughly the same number in each. There's no box that's too many or too few. It's always clear what goes into each box. You don't have to worry about the edges because you can clearly see that 6.1 fits in and 8.9 fits in. Again, this is not the only answer. You know, you could have started at 5.9 and you could have had 5 boxes. I'm just trying to give you a process for making a nice grouped table here. Okay? So this is our example if you want to write this one down here.
What's the probability that this works? You know, you said
Well, this process, the reason I do it this way is because 99% of the time it will work to produce a good grouped table. So for exam purposes, that's 100% of the time.
So here we're dividing the range by the number of boxes.
Yeah, but the range is not, it's not 6.1 to 8.9, because that's too tight. It's 6 to 9. And I just wanted to make it clear, you're allowed to go a little bit less than this and a little bit more than this in your table, but the question is how much, and that 0.7 was kind of like an absolute limit for how far you can stretch it on either side. I mean, the reason for this is because if you are doing a statistics report and you had your first box as 2 to say 6.75, that's a little bit misleading to the reader. Why would that be misleading to the reader?
Because there's no values under 6.
Absolutely. You're making it seem like you have numbers which start at 2, when in fact you only have numbers that start at about 6. So this is the point I'm making when I say this is kind of like a limit to how reasonable you can go either side. Yeah?
So you can't use the value at the limit, right? You have to be just under.
It's not, it's kind of a little bit messy then, because Like here, you couldn't use it because it's open.
Yeah.
So then your 6.1 doesn't go into this table. You know?
Yeah.
In other words, the simple answer is you're giving yourself a little bit of slack at the ends. A little slack so that everything is clear and there's no questions of, oh, but now my data point doesn't fit into the table I'm making. You know?
How do you know that it's open?
How do I get the 0.7?
No. How do you know that it's open or closed?
You can choose it whichever way around you want. My practice is the left is open and the right is closed.
So one has to be and the other has to be coming out. So
Yeah, that's important. One has to be open and the other has to be closed. You can't have both open and both closed.
So you,
That wouldn't.
technically.
Why? I just explained on the side, remember?
So technically you could have ended that.
Oh, okay, okay.
Technically you could have added at 8.9, but if you're having a bit of slack on the left, then you should have a bit of slack on the right to keep it symmetric.
Should it be of equal amounts or?
It should be, but it's again, it's not like this is a rule. It's just a practice, you know. So like we went 0.1 to the left here and 0.1 to the right here. But it's not the end of the world if you went to 9.1. You know, what would be unacceptable is if you went to 10.
But if you went to up to 9.4, would that also be fine?
That'd be okay. You're pushing it though, but it'd be okay. Yeah.
This doesn't seem right.
No, but I'm only giving you guidelines so that you don't do something stupid in the exam, like have a table with 10 boxes,
Well,
but you only have 5 numbers. You know?
Rules were guidelines.
Can I scroll down?
Yeah.
Yeah. Okay. So let's have a look at another grouped table.
The score of the concept.
Okay, quickly, yeah.
Is there a reason you didn't add the 8.25 in the last box and you just forget?
Oh, I just said 8.25. I must have got distracted by something. Okay, thank you. Can I scroll down?
Yeah.
Right, there is another way to write a group table. So again, let's. I'll just write some example data down. So like maybe you have like 5, 6.1, 7.2, etc. Whatever. And I collect all the data and it's in a table like this. 0 to 2, 3 to 5, 6 to 9, and 10 to 12. Oh, that's a little bit off, sorry. 3 to 5, 6 to 8, isn't it?
Yeah.
And 9 to 11. Let's say. I don't know, whatever this is, data, frequency. So let's say I have 6, 7 of these, 8 of these, and 2 of these, as an example. Okay, so often you might find yourself in a situation like this where you don't have the data, but you have the summary as a grouped frequency table like this. Now this table is a little bit different because it's not precisely clear what the ends are here. Like for example, if I had the number 1.5, which box does that go into?
First.
The first box, clearly. 2, well, the first box, I would think. Now what about 2.1? Which box does that go into?
None.
I know.
The
Oh
two-
no.
The two.
First box.
The two.
First box.
Yeah, first.
Because what you need to do here to discover which box your data goes into is you have to round it off. So like if I had a data like 6.1, which box is that getting added to?
6 to 8.
This one. So that becomes a 9 now. So sometimes you get your tables written like this. And it's not clear. So what they would usually have the student do in the exam, this has been an exam question, is they would ask them to extend the table. That is, to actually put in what the interval is precisely. So let's take this one, 3.5 to 5. It's not really 3.3 to 5, because the number 2.99 would go into this box, because 2.99 rounds off to 3. So what is the absolute smallest number you could have that would qualify to go into this box?
2.5.
2.5. Including or not including 2.5? Including. And what is the absolute biggest number that would allow it to go into this box? 5.5.
5.
But open. But open. So like your 5.49 would be okay. So you see what we're doing? We're going back to the previous table here. What has happened?
Doesn't 5.5 go to the next?
How did I fix this last time? There was some other. No. There's some button like. Oh. No. Wonderful.
Does that go on YouTube?
Oh, look what I did. Okay. I can flip my images around. Nice. Alright, well that's not useful right now. There we go, I think. There we go, we're back. Okay. This one here would be 5.5 to 8.5 open. And this one here, 8.5 to 11.5 open. Yeah, we're open on the right and closed on the left.
It depends on.
Again, well, I don't think you could really have it the other way, because the rule for rounding is that if you had a 5.5, that actually goes into the next box.
It's just another source of
Well,
expression.
you-
Yeah, it is.
You could just do the opposite. It's just
No,
simple.
you can't. Like if I said to you 5.5, which box does that go into?
Just read
5.5.
No, it doesn't. It goes into this one. Because 5.5 rounds up.
It's closer.
Guys, listen. 5.5 rounds up to 6, doesn't it?
Yeah.
So it goes into this box. So it must be open here and closed here, because you want it to be caught by this box and not this box. Now what's the upper one here?
0? 2.5.
2.5. Now what is the lower one here?
0.
It depends if it could be positive or negative. So if your data can only be positive, then the lowest value here is 0. However, if your data could be negative, then the lowest isn't 0. What would it be?
Minus 2.5.
Minus 0.5. But in the exam, usually the data is something that can only be positive, like here are people's heights, or here are shoe sizes, or here are IELTS scores. So you can't get a negative IELTS score. So normally 0 would be the lowest one here. Okay?
So it's not necessary to keep all the ranges the same.
No, it is not necessary to keep them all the same. It's good practice, but you'll actually see in some situations they're
This is
different.
realistic, like the algorithm questions.
This is realistic, yeah. Yeah. You got that? Now, unfortunately, you need more vocabulary. So, for each of these are called the class intervals. So if the question said, draw the class intervals, add the class intervals, that means to add the full interval to the table. Okay? You could probably guess, what might you call these numbers?
Sets.
No, the actual number.
Limits.
Yeah, another word for
Range.
limit.
Range?
No, another word for limit. That marks the start and the end of
The
something.
main?
No. Yeah, it could be maybe upper and lower limit, but there's another word. Boundary. So you could call it limit or boundary. And like you said, upper and lower. Okay? The other thing which is useful to know is the width. How wide each one is. As Young Peng noticed, they're not all the same width. Like this one is 2.5 units wide, but how wide is this one? Tray, and tray. Okay? And the last thing is the midpoint. So it's often convenient to know what's the middle in each group. So what's the middle of the first one? 1.25. And here? No. 4,
Four,
6, 7, and 10.
oh,
You add and divide by 2. Yeah?
you mean,
Yeah. Yeah. Now, why is it useful to know this type of stuff? Well, for example, suppose somebody gave you this here, and they asked you to calculate something like the average. Well, you can't really do that because you don't have your data. Because how do you calculate average?
Add the result.
You add up all the numbers and divide by, in this case, how many we have. How many do we have? 10, 16, 23 or something. Okay? But you don't have your data. But what you could do is you could reconstruct your data. So for example, here you have 6 numbers between 0 and 2.5. What is your best guess at what those 6 numbers could be? 6 2.5s. So 2.5, 2.5, 2.5, 2.5, 2.5, and 2.5. Is it really 2.5 6 times? No, because if it was, then what we would have done was just used a frequency table. But it's a good estimate because sometimes you will be too big, but sometimes you'll be too small. In total, it balances out.
So why did you use the width, not the midpoint?
Oh, sorry. 1.25, 1.25, 1.25. Thank you for being awake. Sorry, I had the physics students this morning and they just really just take it out of me. 1.25, 1.25, and 1.25. Okay.
So it's about median and medians.
Yeah. Yeah. What is your best, guys, what is your best estimate for what these 7 numbers are?
4.
4. It's like having the number 4 7 times. Okay? So, this is the key idea here. You start off with your data. You could put it into a frequency table, and you could also put it into a grouped frequency table. But there is a price that you pay for doing this. Although these are quite convenient, you lose information. Okay? So for example, what information do you lose when you go from data to frequency table? So it might seem like you don't lose any information because you still know it, but you actually lose the order. So like if you have the data 2, 6, 1, 6, etc., and you put it into a table, you actually lose the order. You don't know which was first, second, and third. So you lose the order. But if you don't care about the order, then that's fine. And then what do you lose when you go from frequency to group frequency? What else is lost now? The exact values are lost, aren't they? Instead, you only have a range. So you actually lose the exact values. So this is the key idea with statistics. As you summarize the data, you get convenient summaries. But the price you pay is you lose information as you go along. Information is lost. Okay, so there's lots of ideas and vocabulary in this, but not so much in the calculations. So I'll let you try this for 5 minutes, and then we'll go on to something which you learned in baby school, which is average. How to calculate average. You remember doing this in elementary school? Yeah. So just try these for 5 minutes. Question, yeah. You need to head off, that's fine. Are you taking your stuff with you, or are you?
Yeah. So I'll start after you.